So in this case, we are going to consider the last part of our question paper, which is question number 6, which is our module 8, the combined applications of integration and differentiation. We combine all that we have learned on our derivatives and also on our integration. All right, so without wasting our time, we are given on question 6, which is 6.1. Calculate the length of the curve. And there they are simply referring to the arc length. All right. For this curve that we are given, which is written as x squared is equal to y to the exponent of 3, and the limits are being taken given as y from 0 to what? To 3. So, guys, for this type of a question, you can answer it in many ways. You can choose to work with x as the subject of the formula, x in terms of what? X in terms of y. As we are given the limits for y, so meaning to say we're going to introduce the square root or just to the exponent of what? Of a half. So x is the square root of y to the exponent of 3, which simply represents y to the exponent of 3 over 2. Remember the square root concept. So x is written in terms of what? In terms of y. Thus, the limits are going to be for y as we are given here. Someone could have written this equation, y in terms of x, y is going to be the cube root of what? The cube root of x squared. But in that case, you must change these limits to say when y is equal to 0, what is the value of x? When y is equal to 3, what is the value of x? You must have the limits here. They're supposed to be for x when you use this. You must change your limits. So guys, it's going to be a long way that we have to change these limits. Let us just use already the limits that we are given for y. So we're simply going to need x in terms of what? X in terms of y, which is from our formulas. All right. If we are to consider our formula sheet, I want us to check as part of our formulas. All right. We have got this part of our areas. So I want us just to consider this time we are on the arc length. So the arc length, they gave us formulas here. This is for the arc length if we are to consider here. So this is for our arc length. These formulas which are given as S, these ones are for the arc length. So us as we are given y in term, I mean x is in terms of y. Sorry, x is in terms of y. So meaning to say this is the one that we are going to use so that we're going to integrate with respect to what? With respect to y. And these limits c to d, they are for what? Y is greater than c, less than or equal to d. So we are going to use this one as the best formula. If we had our limits for x, we're going to use this one, which has got dx. It is the limits for what? The limits for x. So that is it. As we saw, the best formula that we are going to use is the one that has got the limits, which are for what? Which are for y. So this is the one that we are going to use. The arc length for that y is going to be written as the integral of the square root of 1 plus x and y. There we're going to differentiate. So that's our dx dy squared, our limits taken from c to d. Then after this, we must integrate with respect to what? With respect to y. That's it. So this is our y greater than or equal to 0, less than or equal to 3. Those are our limits. So let us have the derivative part on its own. Then we substitute here to integrate at the end. It's an easy question, guys. Do not even worry for question number 6. It's one of the easiest. All right. So taking your x is equal to what? Y to the exponent of 3 over 2. Let me just increase this one a little bit. So there we are given x is equal to y to the exponent of 3 over 2. What is it that we need? The derivative of x with respect to y. So drop the exponent, subtract 1. Remember derivative, drop the exponent, subtract 1. So it's going to be 3 over 2 y to the exponent of 3 over 2 minus 1. That is what? That is a half. You square it. As we can see, there's a square there. So you're supposed to square this value that you just determined. So that is going to give us square it. So that's dx dy squared, which is equal to 3 over 2 squared. If we square this one, that is 9 over 4. So you're going to have 9 over 4. Then y to the exponent of half squared. You multiply the exponent. So half times 2, that's what? That's 1. So it is just going to give us y to the exponent of 1, which is y like that. So this is what we are given as the dx dy squared. All right. From there, add 1. You must add this one. 1 plus the square of our derivative. It means 1 plus this 9 over 4 y. All right. We can even write the y on top. So it's 9y over 4. Add those two. Combine them. All right. How can we combine this, guys? This one is an easier. Where there's a 1, 1 can be written as any number. 1 can be written as a over a, b over b, x minus 1 over x minus 1, 2 over 2. So you just consider your denominator. Your denominator is what? Is 4. So you can write this one as what? 4 over 4 plus 9y over 4. This is 1. 4 over 4. So that when we are adding, we simply consider the denominators are the same. So we just combine what? The numerators. It will be easier that way. All right. So I have added these two. I'm going to obtain 4 plus 9y over what? Over 4. So this is the part of 1 plus dx dy squared. This is our resultant, the part that is under the square root. So you take this, bring it to the square root. This is the part that we are given here, under the square root. Here, under the square root. All this, you simplify it aside. After having it, you substitute. So that is the integral. Remember, our c, y is greater than or equal to 0 up to 3. All right, so it is the square root of this whole part that we simplified here. All right, so this whole part, we simplified it as it is here. This is the one that we simplified here. We are going to substitute as it is. 4 plus 9y over what? Over 4. Just like that. So that is what? 4 plus 9y like this over what? Over 4. We can integrate this. This whole part is no longer part of our question. We are done with this section. We are done with that section. So here, let us integrate what we are given. How can we integrate? All right, there is a square root. So let's get rid of the square root. All right, we can simplify the square root of 4. Remember, this is a fraction. The square root of x over y is same as the square root of x over the square root of y separately. So we can separate, find the square root of the denominator as it is a single term, that is 2. But we cannot determine the square root of this expression, so it will remain under the square root. 4 plus 9y as it is, it will remain under the square root. Now that we've got this, we can take out the constant. Remember, this is same as what? 1 over 2. So we can take that one out of the integral, the 1 over 2. All right, so it is going to be 1 over 2. The integral of what? Is going to be the integral of this. We are going to remain with this part. Remember, we have taken out 1 over 2. So you remain with the square root of 4 plus 9y like this. Then we can integrate it. This part, it is now in your hands. How are you going to integrate? Guys, you can use the substitution. You can, as long there is something that you can see, use it. Also by inspection. Remember, for this question paper, I've been talking about inspection, factorization. I mean, the integration by what? Inspection. This here is the same as 4 plus 9y to the exponent of a half, if we can check it properly. So we can use our inspection concept here. Remember, the inspection when there is an exponent. When there is an exponent, the integral of f of x to the exponent, you've got this formula in your formula sheet, remember, times its derivative. So since it is given in terms of x, here it is given in terms of y, I'm just going to put y here so that we understand as we are having y there. So this is supposed to give us f of y as it is to the exponent of n plus 1 over n plus 1. As long this one happens that there is a function raised to a certain exponent and the next part is its derivative. Okay, this is our f of y, the one that is raised to the exponent of a half. I want you to see this. Your f of y is what? 4 plus 9y. The one that is under x, this one, inside the bracket. This is our f of y. So we must have its derivative. The derivative is what? That's a 0 here. 9y is going to give us 9. So we were supposed to have a 9 here. We were supposed to have a 9. It was supposed to be times a 9 here. Remember, we are saying this raised to its exponent times its derivative. Derivative there. So the derivative is what? Is 9. But we do not have a 9 there. So once we put that 9 here, we must also neutralize that 9. So we multiply by what? By 1 over 9. The reciprocal, the inverse of 9, 1 over 9. By doing this, we haven't changed anything because this 1 over 9 and 9, they cancel. You look at that. So you're back to the original question. But do not cancel because remember, you had to introduce 9 so that here I have a certain function raised to its exponent. Here I have got what? Its derivative. Once I see this, guys, it means I can simply integrate, all right? This one out of the integral, we can just multiply this. 1 over 2 times 1 over 9 is what? 1 over 18. Let me have this one. So it's going to be 1 over 18. So this is what I'm saying. You can simply integrate this by using our inspection concept, which is telling that once we've got a certain function to its derivative, take that function as it is, 4 plus 9y as it is, raise it to the exponent of n plus 1. So we add 1, it's going to be what? 3 over 2 over what? N plus 1, which is the same 3 over 2. Just like that. So guys, this is what you're going to have. So this is 1 divided by what? 3 over 2, which is going to give us 2 over 3. So it was going to give us 2 over 3 into this bracket, 4 plus what? Plus 9y to the exponent of 3 over 2. So this is what we were going to have at the end of the day. We have integrated by inspection. So I want you to use the substitution, the u substitution. You see that you're going to have the same thing. Let your u be equal to this part that is under the that is inside the bracket. Still we're going to have the same thing, all right? But with our inspection, we can do this direct. As long a function is raised to a certain exponent, what is there? It's its derivative. So we're not having anything. It was just like there's a 1. So as we're supposed to have a 9. By introducing the 9, we must multiply outside of the integral by what? 1 over 9. We're done. Just like that. So let us substitute our limits as we are given. These we can even just consider this one outside, guys. The 2 over 3, you can even take it outside. It's going to be 2 over 3 is going to give us 1 over 27. Is that so? 1 over 27, 1, 9. So that's 1 over 27. Then we can properly apply our limits on this 4 plus what? Plus 9y to the exponent of 3 over 2. Okay, let us use our limits here properly. When y is equal to 3, which is our upper limit, what are we going to have? We substitute 3 in place here, so it's going to be 27 plus 4, which is what? 31 to the exponent of 3 over 2 minus, we substitute a 0 there, so it's going to be 4 plus 0, which is what? Which is 4 to the exponent of what? Of 3 over 2, just like that. So that is it. We simplify what we are given. So this is 1 over 27 times the whole of this part. It was going to give us 6,096 units. This is arc length, so it's just going to be units to 3 decimal places. Guys, as you can see, this one is one of the direct applications. You just have to follow these steps. You just have to follow these steps. Differentiate, simplify that part of the derivative until it's in simplest form. That is when you bring that part to the what? To the formula, the one that you have been working around on those simplifications that you had. When it is a single part, you substitute it back. Then you can integrate. Integrating, it's in your hands, whatever way that you understand here, as long you are integrating properly. As long you are integrating properly. So that is it. Let us consider the other part, which is 6.2, which is on the area. This time they want us to determine the surface area. We must calculate the surface area, which was the surface area generated by the rotating portion of the curve. This is our curve. X squared plus y squared is equal to 9. Between these, so as we can see, we've got the limits for x. X is greater than or equal to 0, less or equal to 2, about the x-axis. So they actually gave us how our area must be determined about what? The x-axis. Again, we have got these formulas for area. They gave us for area. So this was the arc length, and these are the areas here. So for the areas, as you can see, there's this part of y here, the area for the y, and for this one is when you're given parametric equations. All right, parametric equations. So we're not going to work on that one. These are for y, of which we are not calculating for y this time. We are calculating for x. So let's go up. Let's go up here. We are going to notice that there are these two formulas. They are meant for us to determine the areas for x. There is this one. We are calculating area for x there. But take note, it is corresponding to the limits for what? For x. There we are calculating x. But what is it here? Y. We are dealing with the limits for y there. So you must check what you're given. As we have the limits for x, x is greater than or equal to this, we have got those limits up to 2. So since the limits are for x, we must use this one, dx, dx, dx. So this is the formula that is best for our calculation. The limits are for what? For x. So our ax is going to be the integral of 2 pi y, the square root of what? 1 plus dy dx squared. All right, with respect to x, as we saw that formula here, this one. Take note there. This is used when you are given the limits for y. If these limits were for y, but they want you to calculate the area about the x, but they are giving you limits for y, you can do that. It is proper. It is a proper thing to be done. But we must consider exactly what you're given. Just like the previous case, we need to find what is under the square root, which is all this derivative. And here, another thing that you must consider is this part of y here. Take note, with respect to what? With respect to x. So y here is supposed to be in terms of x. We cannot integrate something that has got y while they are saying with respect to x. So this y must be in terms of what? In terms of x. So you must make y the subject of the formula. From what we are given, y squared is equal to 9 minus x squared. So introducing the square root, that's we're going to have the part of y there. So y is equal to the square root of 9 minus x squared. This is the y that we are talking about here that you must substitute. Okay, so it is there. Okay, let's consider this part under the square root, guys. We need to simplify that part until we have it so that we can just substitute our answer there. Let us do this one aside. Since we need dy dx and also to square it and add 1, remember y is equal to this 9 minus x squared to the exponent of a half. We need its derivative here. Guys, from our function of a function, differentiating what is outside, that is drop the exponent. So we're going to drop the exponent, we subtract 1. So it was going to give us 1 over 2. 9 minus x squared to the exponent of negative half. Then you differentiate what is inside. So this is the outer, then what is inside. So you multiply to the inside part. So differentiating what is inside, that's a 0 here, minus x squared is going to give us minus 2x. So we have applied our chain rule. All right. In a better way, we can just simplify by looking into it. All right. So 1 over 2 and this cancels. So you're going to remain with x, which is minus x. So it's minus x over. Why am I saying over? This is carrying a negative exponent. So we are going to write it down as 9 minus x squared to the exponent of a positive half. We have removed the negative. The minus x, it is on top. This is just like over 1. So it's going to be on the numerator. So let's square, because we can see from that formula, there is a square of it. Dy dx squared, the square of it. If we are to square, what are we going to have? That is dy dx squared is equal to what? A negative, when squared, it's a positive. So that's positive what? X squared over what? The square of 9 minus x squared to the exponent of a half. The square, this one, it's simply exponent to exponent. So it is going to be to the exponent of 1. Half times 2 is what? It's 1. So you're going to remain with 9 minus x squared. 9 minus x squared, just like that. So this is what you obtained, and we must add a 1. 1 plus. We must add a 1. So adding a 1 to what we already have here, this is what it was going to look like. 1 plus dy dx squared. It means 1 plus this, what we obtained, x squared over what? 9 minus x squared. So combine it to a single fraction. Remember what I said, guys, 1 is same as any number. So you look into the denominator of the other fraction. So 1 is same as 9 minus x squared over 9 minus x squared. It gives us a 1. All right, so plus x squared over 9 minus x squared. As the denominators are the same, this is what we just want. We can combine what we are given by simply adding the numerators together. 9 minus x squared plus x squared. So that's x squared, and this one cancels. So it's going to be 9 over 9 minus x squared. So this is the sum. When we add this one, this is what we were going to have at the end. All right, this is what we were going to have at the end. 9 over what? 9 minus x squared. Leave it there. It's a single fraction. You can leave it. Then substitute back, because this is the whole part that we needed, this one, under the square root. So I'm going to substitute everything, because we've got everything now. Guys, we've got everything now that is needed on our formula. We have got everything that is needed on our formula. All right, remember we've got y there and this part, so we're going to substitute into our formula. So the area is going to be taken as, we can even take the 2 pi, guys, a constant, take it outside of the integral. Our limits from a to b, the x values 0 to what? 0 to 2. Y in terms of x, it's what? The square root of 9 minus x squared. This one, this is our y. This is the one that we put there in terms of x. So that is the square root of 9 minus x squared, representing this y, times the square root of, so it's the square root of what we obtained, this whole thing. We simplified it. It was the part that we're simplifying here. This whole thing, 1 plus this. It is the whole part that we simplified here, 9 over this. So this is the one that you take. You put it inside the square root. As it is, you put it inside the square root. So let's put it inside. It is going to be 9 over what? 9 minus x squared, as it was given there on your calculation. So that's, we're going to integrate everything with respect to what? With respect to x. That is where we are. So you see, once you do this simplification in a proper way, guys, this is the most important. Once you do this simplification in a proper way, you won't have challenges, because here you're going to see that I have a square root. Remember, I explained the concept of square root of a over b. We can separate square root of a on its own, square root of b on its own. So in our case, we were going to have the square root of 9. We cannot simplify this, but we can simplify the square root of 9, this one on top, as it is a single term. So square root of 9, that is 3 over what? The 9 minus x squared cannot be simplified. We cannot determine its square root. It is the same as this one. We cannot simplify it. So it will remain under the square root as it is, 9 minus x squared. But the 9, this one, we can determine its square root. It's a single term. Remember, square root of a over square root of b. So 9 on its own, but the denominator, we cannot simplify. It remains under the square root. With respect to x, it is an advantage that we cannot simplify these square roots. Why? This is same as over 1. So these can cancel. They're the same, guys. Numerator to the denominator. Do not waste your time. Cancel that. And after, you can even take out the 3 that is remaining, as it is a constant. Multiply it to the one that is outside of the integral. So 3 times 2, that is what? 6. So it's going to be 6 pi. The integral of what? As we can see, we've removed everything. There's nothing left in the integral. It's just like 1. So it is just dx. You are just integrating with respect to x. So integrating 1 with respect to x gives us what? It gives us x. So even if there was that 3, you're going to have 3x. So here it's just 1. So that is it. So it's going to give us 6 pi. The integral of 1 with respect to x, that is x. Our limits from 0 to 2. We can apply these limits, upper limit minus the lower limit. Then we multiply to the 6 pi that is outside. So that is it. That is it. 2 here. minus 0. So 2 minus 0, that's what? That's 2. And 2 times 6 is going to give us what? 12. So our answer was going to be 12 pi square units, just like that. 12 pi square units, or you can have it as a decimal. It's going to give us 37,69923 decimal places. It is our area, surface area. So this one is one of the easiest, guys. Revise as many topics. Revise as many question papers. You see, it's a repetition. Even the layout of the questions, how they cancel this and that. It's a repetition. It's a repetition here. They repeat such questions. So the more you revise, the more you can actually understand the idea, because there are also others that can be in this format where the area for x is calculated from the limits of y. So do many question papers, you see those questions. Or we can have those ones for the parametric, all right? We can have these ones for the parametric. If you consider this part here, these ones are for the parametric. Also, even for the arc length. Remember, we talked about the arc length here. There is also the one for the parametric. This one, it is used when you're given parametric equations. So do a lot of question papers. You meet those formulas in use. Once you use a formula, guys, it is the same thing how you use it in your final exam. So don't be stressed, don't be scared, just revise. Do as many question papers. You are going to find out that Mathematics N6 is actually the easiest compared to Mathematics N5, because it's a direct thing. You just follow steps, you just follow them like this. So to follow those steps, a lot of questions. Let's do a lot of them. Where we do not understand, or if there is any question paper that we have been going through and we do not understand that question from a certain question paper, let me know so that we can work on that one, especially for those who are under membership, so that we can work on those questions on our membership platform. So that is it, guys. Till we meet again.